My lab at Bar-Ilan University is called the Complex Network Dynamics Lab. We want to understand the dynamics. We want to be able to translate our structural insight on how these networks are constructed into an understanding of their behavior. Let me talk to you about two potential applications. For example, consider a social network. It's a static pattern of who's connected to whom, who's linked to whom in terms of individuals. But that social network is precisely the roadmap upon which epidemics travel and spread from a local outbreak to the global population. So we want to be able to predict the patterns of spread of an epidemic. How do viruses navigate this network? And if we're able to predict that spread of the epidemic, then we might be able to influence it. For instance, how can you immunize most efficiently the social network and prioritize the individuals or the cities that you need to immunize first and which ones you need to immunize later? Can you make minimal interventions on air travel so that you get maximum impact on number of fatalities from a potentially globally spreading epidemic? So here's our view. We think of the network as a roadmap, but the roadmap is static. If we want to understand how viruses travel, we need to think about them as cars navigating this roadmap. And our goal is to provide the network GPS, to provide a prediction of when, where, and how strongly the epidemic will impact different locations in the network. But now that we have this thought of viruses spreading on a network, we can expand this. In 2003, everyone in New York was standing in the dark. It was the second largest blackout in history. There were fatalities, there was a tremendous economical cost, and a lot of inconvenience. What happened in the 15 years since 2003? Well, in those 15 years, several things have happened. One, our networks have become interconnected. There's no such thing as a blackout in the modern world, because such a blackout will cause a failure of the internet, which in turn will cause a failure of communications, traffic, medical systems. So we are thinking about this doomsday event where a major blackout might hit us again. But how do we mitigate this major blackout? Well, we can think about it as a spreading process. In a sense, it uses the same mathematical tools as the spread of an epidemic. It's a different system with a different behavior, but that can be captured within the same mathematical tools. It starts from a local failure and then spreads along the network. And network GPS can provide you a prediction to forecast exactly where the failure will be at given times, and perhaps in 4 or 5 years from now, also an algorithm. Because while blackouts are sudden, they are not immediate. They take 3 or 4 hours to build up. 3 or 4 hours is not enough for crews to come and fix things, but it's definitely enough for an algorithm, a smart algorithm, that knows how to navigate the network and shut down potential power stations deliberately to prevent the spread and mitigate it in real time. So this is our goal. We want to understand, predict, and ultimately influence and steer these complex networks into desired directions. And I believe that in maybe 5 or 10 years from now, what was once considered science fiction will actually become a reality.